Okay, and this is now the shape that we will be creating in every other CAD system. And there you go. We got the exact same result we got in Alibre using the same workflow. Okay, but again, you can see that if I hit P and hide the planes, you can see that I got the exact same geometry, exact same result in Onshape by doing the exact same things. What do you know? We have the same thing in Alibre, in FreeCAD, as we had in Alibre, as we had in Onshape, as we had in Fusion. Okay. Mistakes were made. 2 of them, in fact. So watch through the video, try and find them, and comment down below what they were. Okay, the mistakes I'm talking about is not using the exact same dimensions or constraints or whatever. So not getting the exact same shapes between CAD systems. And if you find it and you write it in the comment correctly, you will get a shout out in my next video. Uh, Everyone who finds it will get a shout out in my next video. So enjoy. Hello and welcome to the second video in this series where we see design strategies and methodologies that are shared across parametric CAD systems and how we can apply them to design what we need to get the result that we want uh, despite the actual CAD system that we're using, right? So today we will be talking about the extrude command, which is the simplest way to make a solid. We'll be talking about the options it gives us and the shared options across CAD systems and the prerequisites that it has in order to perform correctly. Now, for those of you that are a bit more familiar with Parametric CAD and the Extrude command, I will not be showing you every option uh, in the Extrude command in every CAD system. We will be showing the basic, the core functionality of it. Uh, the reason for that is some CAD systems might have less or more options than other CAD systems. However, the options that a CAD system might lack uh, provide a geometry that is definitely obtainable with the use of other tools. Okay, so the spirit of this series is CAD. We will be showing you how to get the result you want in any CAD system by making a more basic use, if you want, of each command and each feature. So without further ado, let us move on to Alibre. I've already started the sketch here. Let's click out of that. So we will be discussing about the ideas and definitions here in Alibre, and we will be taking that same workflow to other CAD systems to see how they are similar. Now, uh, I want to start by defining a helper shape, I'm going to call it. Okay, first, and helper shape is going to be, simple rectangle with one of its faces. Um, so one of its faces is going to be an arc. So these, uh, Alibre has automatically made these equal, which is what I wanted. Let's make this 15 millimeters. We want to make this 100. We want to make this an arc 65. I'm making the origin and the center of the arc vertical. That way, this shape is always going to be symmetrical around uh, around this axis, which is the y-axis. Okay, and the YZ plane. Okay, you will see it when we go back to 3D. And finally, I want to make this 150 millimeters. So this is my shape. Now it is fully defined, and I want to make a solid out of it. just like that. I hit the E hotkey, or I can just click on the extrude command. And what the extrude command does is it will take that sketch, okay, and apply a height to it and give me a solid. Now, uh, if you want to if you want to go a bit more technical on how the extrude command works, let's first of all, let's say that for the extrude command to work, we need a sketch that is closed. Okay. Another term you might hear when discussing CAD systems is we need a sketch that is watertight. That's a good way to think about it, because you can imagine that your sketch is the outside of a vessel, and if you pour water into that vessel and it holds it, then your sketch is watertight. If, for example, there's an opening where two corners are not connected, then the water will flow out, as it were, and that's not a watertight sketch. If you're curious about why that is a prerequisite in any parametric CAD system, is because your sketch is defining the boundaries of the manifold, right, that is going to be created. Your solid in topology is a 3D manifold, okay? And a three-dimensional manifold has two-dimensional boundaries. In any case, if you want to learn more about it, that's how you will look it up, right? It's the definition of manifold and manifold boundaries in topology. That is why your sketch needs to be closed. Other than that, the way that the solid is created, we can give it another definition. Now, the solid we will create is a set of points in space, and if you account for every point in space that has a particular set of properties, then you get that solid. Now that is a geometric locus. Okay, that's the official scientific term, if you want, of it. It's a geometric locus. So the solid that is going to be created is the geometric locus of any point that has the two following properties. First of all, if you project that point along the normal to the plane that we created our sketch profile, and that projection falls within our sketch, then that point satisfies the first property. Okay, let me rephrase that. It is the sum of points that, when projected along the normal of the plane that we sketched on, okay, that projection falls into the boundaries of our sketch. Okay, that is one of the properties it has to have. The second one is defined here, right? It's the depth or dimension. You might see this being called in another CAD system. So the second property is that the distance of that point to the plane that we sketched on needs to be less or equal to these values. When I make this a value of 50, this solid represents every point that, when projected along the normal, and you will very helpfully see that we have an arrow here. That arrow gives us normal direction to the plane or face that we have sketched on. Okay. So this yellow thing, right, is the sum of the points that, when projected along this normal, fall inside or on the boundary of our sketch, and also have a distance to that plane less or equal to 50 millimeters. Okay, so that is the geometric locus of points that create the solid through the extrude command. Okay, now the extrude command, so that is the core of it. right? That is the gist of it. That's what the extrude command does. But there are some other basic functionality that you will see in any, and I mean any, CAD system. So one is to depth. The other one is you can make your extrusion go symmetrically uh, on, be symmetrical to the plane that you sketched on. So go symmetrically on either side of the plane that you sketched on. In order to make this a bit more observable, let's turn our planes on, and you will see that I sketched on the XY plane, right? And now that I've selected the mid-plane type or option, my 50 millimeters are 25 millimeters either side, right? So if I make this 75, you will see that it's becoming larger by an equal amount on either side, okay? Whereas if I say to depth, I can either go one side or click reverse and go the other side. Okay? So with mid-plane, I'm always symmetrical to the plane that I sketched on. And we have another option which gives me control over the size that will go on either side of the sketch plane. So let's say that we want 35 on one side of the plane and 15 on the other. Again, what we have here is the same solid. It's 50 millimeters in height, but that height is divided on either side of the sketch plane, which is the XY plane, and by the amount that I selected here with these values. Okay. The final type I want to talk about is the to geometry type. You will find this in every CAD system. Now, in order to discuss this, we will need to make a second sketch and a second extrusion. Okay, so let's sketch on the XZ plane now. Okay, and let's make an isosceles triangle here. So we're starting completely arbitrarily. Okay, let's talk about design intent again. I want an isosceles triangle. I want the base of it to be horizontal. There we go. I want the base of it, the midpoint of the base to be the origin. Okay, there we go. And I want it to be an isosceles triangle, so I want these two edges to be equal. Now this is an isosceles triangle, okay? But this is, this can be an infinite number of isosceles triangles. So let's narrow it down using dimensions, okay? So we express our design intent with constraints. We narrow it down using dimensions. So let's have a 35 degree angle on the equal scales, and let's make this edge 40 millimeters. Now this is a very, very specific isosceles triangle. Now this cannot be any other shape anywhere else in space, and that is why it is black, and that's why it's fully defined. Now, if we extrude this, we get the same options, right? Now, I don't want to go that way. I want to go the reverse way. I can give it a numeric value here, or I can drag the arrow to any point I want. Okay. And look, if I give it a value of, let's say, 112 millimeters, okay, you will see that although it touches, oh, does it touch even? Let's see. It does by a bit. Although it touches this face, it doesn't fully merge into it, right? So I still have one solid, but it has a very, very weird geometry there, right? And what's more, if I go back to my first sketch and increase this distance by a little bit, and generate to last. Now, look, this triangle now is floating in space. Okay, not only that, now my part has two solids in it, and not every parametric CAD can handle this. So if we go back to the second extrusion and use that option we were talking about, the to geometry option, well, the preview goes away because the system is asking us for a geometry target. Now let me select this. I click on that, hit OK. Look what happened. Okay, now the end of my extrusion is no longer a flat face. It is now a face that hugs, right, that conforms to the face I selected as the to geometry argument. Okay, and what's more, if I make this even further back and generate to last, it will update automatically, parametrically, right? So those are the options of how you can use the to geometry option. Let's just bring this back into position. Generate to last. Finally, let me talk about another very important option of the extrude command. Let's do it here, which is the draft angle. Okay. Now this is extremely useful when we're making molds for plastic injection, and that's why the terminology is borrowed from injection molding manufacturing method. Okay. And then in injection molding, a standard angle that we might need for a good ejection of the finished part of the mold is 5 degrees. Now, if I give that a 5-degree angle, first of all, the outward option got clicked because this is a positive number. If I unclick it, this becomes negative. Okay. So what is the draft angle? Well, it takes the plane that I sketched on, uses that as an initial plane, and then every other face created from that extrusion bows out at a 5-degree angle. Okay, and that's what we would do basically in an injection molding situation. Let's make that 2 degrees. Oh, sorry for that. Let's make that 2 degrees so that it's a more, it's less pronounced. Okay, so this is our result. Okay, and because the plane that this draft angle starts from is the plane that we sketched on, if we use the mid plane or the dual depth command, we will get the opposite angle on the other side of our extrusion. Okay, so we need to bear that in mind. So let's go back to mid-plane. You can clearly see what's going on here. Okay, an edge, a ridge is created here. Okay, a ridge is created here, and if I go ahead, let me hide my planes. Now, if I go ahead now and select this plane, look what happened. Okay, first of all, I'm not sure you can clearly see it. Maybe from here it'd be more obvious, but even though this part of the extrusion is now outside the shape because I made this mid-plane and I lost half its height from this side and I added it to this side, because this is the geometry that I'm ending at, okay, even the exposed part of the second extrusion follows A, the arced nature of this face, and the draft angle of this face. Okay, so very powerful stuff here. You can create very complex geometry using only the extrude command, which is the simplest command out there. Okay, I just wanted to show you what the draft angle command does. You will find this command in any CAD system. Let's just make this to depth. So we just put this all the way up over the edge again. Okay, and this is now the shape that we will be creating in every other CAD system. So let's go and do this now in Fusion. So we start in Fusion.
Let's make our helper face first. Sorry, helper extrusion first. Okay. And these are equal. And these are 15 millimeters, and this is 100 millimeters. This is an arc of 65. The origin and the center of the arc are vertical, and the distance between the origin and this edge is going to be 150 millimeters.
Okay. Now, there we go. This is going to be 50 millimeters. Okay. And here is the 2 object. This is the equivalent of the 2 geometry. Option we found in Alibre. And the Fusion breaks it down to 2 different options here. Here is the dual depth, it's called 2 sides here, and the mid-plane, it's called symmetric here. So just to show you, if we put symmetric, we get an additional option here if the value that we give it is half the length or the entire length. Okay? And the draft angle, the option for the draft angle that we saw in Alibre is now called the taper angle. Okay, let's give that again, positive means outward, negative means inward. There we go. Okay, you can recognize the shape. It's the same one we got in Alibre. Let's cancel the symmetric one, make it one side. And now let's create our isosceles triangle.
So let's make it up here. So what did I do? I made the origin, the midpoint of the base, and I made the base horizontal. I then made the 2 edges equal, and then started giving dimensions.
This is the very specific isosceles triangle I wanted to get, and we extrude again. I hit it here because I've hotkeyed it and I wanted the room up in the toolbar. So we either hit E or extrude. Now we don't want to go that way. We want to go that way and up to that face. So to object, select the face, and there you go. We got the exact same result we got in Alibre using the same workflow. Okay. Which is the point of this series, to show you that workflows are shared across CAD systems. So now let's go to Onshape. Okay, let's start a sketch.
Here, we want a line. There we go.
Click escape, hit escape too early. Too soon, Junior. Are you guys too old to get that reference? Anyway, I'm making
these 2 lines equal. I want a 3-point arc up here, and I want that arc to be 65 millimeters. I want this to be 15 millimeters. I want this to be 100.
By the way, you can follow along even if your CAD system is in inches. You can use the exact same numbers. You don't even need to convert it, right? It's about seeing the shape.
And then we want the origin and the center of this arc to be vertical, so I get the vertical constraint. Okay, but I want to see the constraints. It helps me visually to know what I've been doing. And I want this to be 150 millimeters. Okay, there we go.
So now we hit extrude. Okay. We want this to be 50 millimeters high. There we go. And draft, right? Draft, which is the term borrowed from injection molding. Now here, I don't know if the minus sign will work. It doesn't really work, but you have an option to do it the opposite direction, inwards, right? And what I see now, which is very helpful, it shows you where the profile would be if you hadn't drafted it. Now that's helpful. So we click OK, and then we go ahead and we make our isosceles triangle here.
All right, now let's make it out of the way. This is definitely not an isosceles triangle. I want the origin to be the midpoint of this edge. I want this edge to be horizontal. Now I want it to be an isosceles triangle, which means I want these two to be equal. Okay. Hey, come on. Oh, what happened there? Control Z. Anyway, let's give it a value for this angle. That's definitely going to work more reliably. And let's give a value for this edge as well.
This is the very specific isosceles triangle I've been trying to get. All right, cool. Hit OK, and now we want to extrude that. And we want to extrude up to a certain geometry, specifically this face. Okay, now this has more options. Sure, why not? Up to this face, because of the specific nature of Onshape, you need to click Merge All. You need to make sure that, no? It merges it automatically, it seems. Okay. But again, you can see that if I hit P and hide the planes, you can see that I got the exact same geometry, exact same result in Onshape by doing the exact same things. And finally, let's go to FreeCAD, our final CAD system. Create a new file. Sorry, my mouse doesn't click sometimes. I want to go to the part design workbench, which is the parametric design workbench. Create a body, create a sketch, XY plane. And I start with my target body. All right, and I want the 3-point arc. Okay, now I want these two lines to be equal, and then I'll start dimensioning them. I want this to be 15 millimeters. I want this to be 100. I want the radius of the arc to be 65. Zoom in, so not every dimension falls on top of the other one. What else? I want the center of the arc and the origin to be constrained vertically, right? There and there. And finally, I want a vertical dimension between these two to be 150. Okay, I'll put this out of the way. So we close the sketch, and again, FreeCAD doesn't call it extrude, it calls it path for some reason. Okay, I want a height of 50. Again, extrude parameters, right? We have the two dimensions, two different dimensions. The second length is here, so 50 and 10. Now this is 60 millimeters. I could do this 35 and 15 to be the same as what I showed in Alibre originally. If we go back to dimension and hit 50, the symmetric option is a different, you click differently here. Let me see if I show the different planes here, you will more clearly see what the symmetric option does. Okay, you see this? It just makes it symmetric. Okay, and we have our draft angle. So I'll make this 2 degrees. It went outwards, right? So I want to make this minus 2 degrees, and it's going inwards. Okay. You will recognize this shape by now. We've seen it so many different times. And now I will create my second sketch on the XZ plane, which is going to be my isosceles triangle, which I will design arbitrarily and then constrain. The midpoint constraint works a bit differently here, so I want these 2 points to be symmetric about the origin. Okay.
All right. I want these two edges to be equal, and I also want this to be horizontal. All right. And this is my design intent. Now I want this angle to be 35, and I want this length to be 40.
Okay, there you go. Here's my sketch. I want to pad it. And now, up to face, right? I select up to face, which is the same terminology as in Onshape. It was 2 object in Fusion and it was 2 geometry in Alibre. I select the face. What do you know? We have the same thing in Alibre, in FreeCAD, as we had in Alibre, as we had in Onshape, as we had in Fusion. Okay, so same workflows, same sketches, same dimensions. We use the same constraints and we get the exact same result in FreeCAD. Proof that you can get the same result with the same workflow in any parametric CAD system. So I hope you liked it. I hope you enjoyed it. If you did, hit subscribe for more videos of this type coming your way. If you liked it, hit like. If you didn't like it, hit dislike. I want to know if you didn't like it. And I hope I see you in the next one.